Hello and welcome to a video walkthrough of the X280 VS Code setup tutorial for macOS. Please note that this is recorded for X281 students by an X281 staff, so please do not contact X280 staff in regard to this video tutorial. First, we're going to install macOS command line tools that will be used throughout this tutorial. I'm going to open the terminal using Launchpad. Then I'm going to run the command as listed here. Okay, then click install. If it doesn't pop up, you can go in the dock here and click install command line developer tools. Then I've already read this agreement. Make sure you read it before proceeding. Then click agree if you agree. Then wait. This estimate usually has a long time, but it will slowly shift down towards the actual time. All right, now that it's installed, we can proceed. I type G++ -- version like listed here. On macOS, it's Apple Clang, so it doesn't matter for this class, but just an important note. Then we're going to install the Homebrew Package Manager. This will let us install a bunch of different cool tools that we'll use. So I'll just double click this, copy it, and enter it here. Another common mistake is I left in this $sign at the beginning. That's just indicating that this is a command line command. So I'm going to go ahead and delete that. Press Control A to go to the beginning of the line, then arrow keys to move around, and then delete key to delete the $sign. Okay, I'm going to type in my user password. This is the same password you use to log in. Then I'm going to hit enter. Okay, now I'm going to add it to my path as listed here. This time I'm not going to double click so I don't accidentally copy the $sign. Now I'm going to close and reopen the terminal as listed. Then I'm going to type the command to check my version. Cool. Now I'm going to install the recommended CLI tools. I'm just going to type this one out because it's not that long. Then I'm going to go to my home directory. Then I'm going to make a folder. In this case, I'm going to do X281 because this is for X281. It's been created, as you can see. This is an important note here. You don't really want to use spaces in your paths because it can cause trouble with different tools. This is something I've personally experienced a lot. It's very good to keep your stuff without spaces. Now, for the rest of these things, these are all troubleshooting or how to use the command line. If you're interested in that, that's out of the scope of this video, but you can go and explore that on this page. Right, now that I've installed the command line tools, I'm going to go back. I'm going to go ahead and check the compiler version and debugger version. Looks good. And then I already know how to use the command line interface. I'm not going to cover it in this tutorial, but you can check that if you're not familiar with it. Now we're going to check some installation things. So first we're going to check the version of macOS we have. In this case, I'm on the latest macOS Sequoia 15.4.1. Just have to make sure you have 11.1 or later. Then I'm going to use the Homebrew Package Manager to install VSCode. Now the VSCode code's installed, we can either open it from the Launchpad or from the command line. I'm going to open it from the command line. And here you can see it's opened. I'm going to drag it to the right. Next, we're going to install the Microsoft C/E++ extension. Right here. And as it's noted, you don't need this extension pack with the 3 things, just not necessary. Now we're going to get the code LLDB extension in order to get debugging support with LLDB. Then trust publisher and install. Finally, I'm going to clear out the search panel with this, and you can see that we have C/E++ and code LLDB installed. Now I'm going to close the window. Then I'm going to create a folder for our project. So in this case, I'm going to navigate to X281. Then I'm going to make a folder here. They're using p1-stats. I'm going to use p0-statistics because that's our first project in X281. Then I'm going to enter it. A very important note here, please don't put any spaces in your like folder names or file names because it can mess with the tools that you use to program and it'll just give you more headache than necessary. Now I'm going to check that I'm in the right folder by doing pwd, print working directory, and you can see that I am in p0-statistics. Now I'm going to do code dot to open a VSCode instance in this folder. The dot here means the current working directory, so as we showed above, that's the p0-statistics folder, but you can also do code space and then the path, the full path, like this, p0-statistics, or even a relative path, like this. But I'm just going to do code dot. Next, I'm going to say, yes, I trust the authors. Of course, you have to trust us sort of if you want to get your grade. Then I'm going to click terminal up here and new terminal. Then I'm going to download the files. Here, they're using the 280 tutorial project. I'm going to use p0-statistics. Click this hamburger menu, then starter and sampler files, then double click this, copy link, go here, wget, paste the link. You can ignore this for now. Click enter, then tar xvf p0-statistics-files.tgz. Then I'm going to move all of the files out to our main folder. The tar command creates a new folder just because of how we packaged it. Then I'm going to remove the old folder and the tar file. All right, now we have just the files we need. Continuing, if you open project 0-cpp, again, you can ignore this. I would actually say don't show again for this extension. Say no to that. You can see the project 0 code. Notice here that the file name is italicized. That means that if you open a new file, it will be replaced. There's two ways you can keep a file. So you can either double click to open, that'll change it to normal, or you can single click and then double click the file name up here. Anyways, you can see the basic project 0 code here. We're not going to go through how to do project 0 in this tutorial, but now you have the code for it. Then can inspect the makefile. So this is pretty advanced. Again, we won't cover the makefile in this tutorial, but you only need a few things in here. Again, I'm going to ignore this makefile tools recommendation. Now we don't need to do the starter file stuff because we already did that for our p0-statistics. Then we don't need to rename any files because of how X281 sets up their projects. If you want to add files, you can go here and then do whatever. In this case, I just did random stuff and then .cpp. You can also use touch to create a new file. That'll just make an empty file. Now we're going to compile. So in this case, they use make main.exe, and you could do that with make project 0. Another way I usually like to do is make debug for debug executable, make release for release executable. That's the same thing as project 0. But again, our focus isn't on the make file. We're going to go over debugging. So I'm going to create a launch.json. I'm going to click this button, then create a launch.json file. You might be prompted to select a debugger. And as it says here, if you're prompted, make sure you click code LLDB. I know it says the other one suggested. No matter what it says suggested, click code LLDB. Then, if you're prompted to select a configuration, like we are, we need to select code LLDB launch. So in this case, that's here. You might have to scroll, but either way, code LLDB launch. Next, we're going to make sure our program is correct. So in this case, it says executable file in these brackets. Well, that's not the name of our executable file. Our file in this case is project0_debug. In general, when you run make debug, your last thing here will be your executable name, and that's what you want to put here. Next, we're going to launch the debugger with this play button, and you'll have to type in your password here. And you'll see if we go to terminal, we get error no mode specified. That's fine. If you look through the P0 code, we actually just haven't implemented modes yet. An important pitfall here is that if you don't rebuild with make debug, your code will be out of date. So like, for example, it says error no mode specified. If I go and change that right now, like just add in some keyboard spam and save, and I click debug again, it's still no mode specified. Only when I run make debug to rebuild does it update. Now, another tricky thing is if I run a different compile thing like make release, it still doesn't update the code. So you'll see I reverted the change, but it's still there. I have to run make debug to build the debug target in order for it to update in the debugger. If you're having trouble running your program, the launch.json is usually simple, so you can go ahead and just delete it here in this .vscode folder and then start over. As for configuring the debugger, the default things here are fine for program and CWD. You want to make sure it has this workspace folder thing, and then your program is, workspace folder with the brackets and stuff, then your debug executable. So another thing you're going to want to do, enable sanitizers. So that'll help you detect bad behavior. In this case for 281, we're going to go comma, then just copy here, then paste it in. We don't need this extra comma at the end because there's nothing after it. Then another setting is turning off showing disassembly. So we can go code, settings, then LLDB show disassembly. Disassembly may be helpful, but for this class, it will just be confusing. Now, running program on command line, we're not going to cover that in this tutorial. But if you want to add command line arguments, there's a couple things here. So in terms of this project, you'll see when you actually do it that there's two command line arguments. One of them is -h, and the other one is either -m. So like -m, no resize. There you go there. Or we could do -- mode or -- help. Basically, you'll have a list of strings here, and importantly, anytime you see a space, so if I instead did -- mode space reserve, this is a warning. Should be alarm bells in your head. You should never have a space in these strings. If you ever have a space, they should be two separate strings like this. Next, for input redirection, it's covered here in the CLI tutorial section, but this is important for 281. All of our projects use input redirection and output redirection to deal with like input to your program. So in this example, that's the sample data. To enable input redirection and output redirection, you'll do std.io, then make an array. The first argument will be your input file. So in this case, that's sample n.txt. Then your output file. So in this case, I'll just do like abc.txt. Then this third one is your error output. So by default, this goes to your terminal. Anytime you have like exit or see error, I'm just going to leave it as null. That'll keep it to the terminal, but I could use a file name here to output to a file. And again, make sure this here is LLDB. Make sure you select LLDB. You should not be using CPP debug. Now I'm going to do debugging. So you're going to have these things called breakpoints. What a breakpoint is, it will basically, right before a line's about to be executed, it will stop the program and you can see the state of the program. In this case, I'm going to put one on line 56, then make sure I recompile. Then I'm going to click this plus button or play button. And you can see we got argc is 3, argv is this string, and like choice is 0. We can click this button, step over to go align. Now we're at this while statement. We can go align, etc. And now the program's exited, the debugger terminates. If we go again, let's place another breakpoint. So right here on line 59, click play. Then if I click this play button, it will either go to the next breakpoint if it can, or go until the program terminates. So we have another breakpoint. In this case, it stops at it, but if we click it again, there's no more breakpoints, so it ends. Then there's step into and step out. So we haven't set up command line handling, so it's never going to go inside this H and M case, but we know that it goes in this error no mode specified. So I'm going to put a function call here, print help. Then I'm going to recompile and place a breakpoint here. Now I don't want these breakpoints anymore, so I'm going to go ahead and delete them with the menu down here. You can also delete it by double clicking, clicking with 2 fingers, and then remove breakpoint. Then I'm going to click continue, and you'll see it actually didn't trigger. I wonder why. Oh, it's because invalid option. So this is where debugging comes in. I know that I was mistaken when I said this, right? I thought it was going to no mode specified, but it actually went to invalid options. So I'm going to move this function call into here. Then I'll put a breakpoint there instead and remove this old one. Another way you can remove them is just by clicking. You can also disable to temporarily disable them, but not actually delete them. Now I'm going to recompile because I changed the code. Then click the play button. And now we're here. Now I don't want to skip over print help. I actually want to see what's inside print help. I could make a breakpoint in print help, but print help is kind of far away from my code. I just want to see it here. So I pause here, then I click step into, and it will actually go inside of print help. So we can see that the command here is this string because we did argv. Then if I step forward, it will print this usage line. It's running, right? And then if I want to break out of here, so if I want to go back to the function I was in, just as I stepped into print help, I'll now step out of print help. Then I'm going to click continue, and the program will exit as usual. So if we go into abc.txt, it did print the output into here. And that's because we had output redirection. Then troubleshooting, we won't go over that, but if you have any issues, feel free to look through that and then post on edit if they don't get resolved. All right, thank you for watching this tutorial and good luck.